Good evening, class. Tonight we're going to quickly review the videos that you saw last week and move on to some new matters. We have, let's see, first of all, we have a construction video that you saw and one that I made. We're just hitting some highlights. I did overlook a few things that I'd like to mention tonight. One, when you're dealing with an outside foundation wall, some of you, I guess, have core bits to go through these core drills to go through these walls, which is great. I never had one of those. I always used the jackhammer. In any case, the tar that they put on the outside, I guess I don't know if it's painted on. I think it's sprayed on these days. That's called damp proofing, and as you can probably guess, it's just to keep moisture or some moisture from getting through the wall. Uh, the other thing you might run into, and I remember this towards the end of my time out in the field, was styrofoam or a 2-inch foam. I don't know if it's styrofoam, but it's a 2-inch very dense foam that's actually stuck onto the foundation wall. They actually stick it right onto that damp proofing before it really sets up. And as also you can probably guess, the reason for that is to give the basement some insulating value. Now, something that we don't really get involved with in our trade, but it's occasionally you'll hear the term, and especially if you own your own house, do some side work, construction side work in your own place. It's called R value. Insulation for 2x4 walls. It could be either, used to always be a R11, which is the resistance of a material to the flow of heat through it. And the second then the insulation became, I guess it's more dense. I don't think the material changed. And now the insulation has a value of 11 or 13. Again, not our concern. Just be familiar when you hear R factor, what that means. Okay. I just got another screen pop up. Hold on. Bear with me here for a minute. I got to get rid of this. And my tech support person is not here, so this could be the end of this video. Let's see. I don't want to hit the wrong X. See what happens here. Okay, we're back. I don't know where that came from. Okay, so 2x4 wall would be typically R11 to maybe R15, somewhere in there. Okay, this foam, this hard foam, is about an R10. I used it on the inside walls of my house last year to insulate the walls before and I glued that to the wall, and then I put green board, which is water resistant sheetrock, glued to that, and then over that some beadboard. But it has an R value of 10. I suspect that the stuff that I used in the basement is the same as or similar to what they put on the outside wall. So the difference will be in a house that has this styrofoam, I call it styrofoam, foam, you're going to have walls that already have pretty good insulation. It's almost as good as a 2x4 wall. And those of you who have been around the trade a bit, you've probably noticed in the wintertime, once in a while, you'll be in a house, especially on a super cold day, where there's actually frost on the upper couple of feet of the foundation wall, because concrete has hardly any insulating value whatsoever, which I'm sure is no surprise to you. It's very cold and allows the heat to pass right through it, breaks the wind. So that's what that insulation is all about. Now, how does it affect you? Yeah, it's nice to know. But when you go to a house and the boss tells you, without going there, measure over from the corner of the house 8 feet and measure down so far and put a hole through. Or he just shows up at the job and marks a hole on the inside where he wants you to drill through. Okay? It might have already been dug out on the other side. Good chance that it has, because if your boss is smart, he'll wait till the septic tank is in. Don't rely on other people saying where it's going to go and it's not there, because once in a while, they're wrong. And then you're the one that has to take all of that piping out of the wall and redo it, which has happened to me. So um, he marks the wall, and you get set up, go on the outside, and you say, hey, there's styrofoam here. Now, if you have a core bit, I think you're going to have to do the same thing. What I used to do is get what we used to call in the Army, a D-handled shovel with a sharp point, and cut the styrofoam several inches beyond the size of the hole. So we'll say the hole is that big. I would go about that big, right, to get it all out of my way. And I just cut the styrofoam right out. Just cut it out, pull it out, okay? It's out of my way. All right, so that's how you deal with the styrofoam. Now, if anybody's got another way to do things, let me know when we go live. Okay, let's see what else I want to mention. I think that was it on the construction. Like I said, I just gave you a brief overview of what I've found that would relate to what we do between our Silcox and now you know about going through the wall with your septic system line. I mean, with your 4-inch building drain. Excuse me. Okay, the other video was about, I talked about fixture units. Now, if you want to take a look at, I'll look at it again, but it was on page 168, 169. And these I'd advise you to remember. 1.5-inch pipe can handle up to 3 fixture units. Good example, what that means. 2 lavs, 1 each. A lav and a tub, although I don't know that you'd want to do that, but you technically can do it. Or you could even have 3 lavs on it. When you jump up to 2-inch, you got a lot more flexibility here. You got 6 fixture units. 2 tubs, 2 sinks. Comes up to 6. So 2-inch will handle quite a bit. And the last one I want to talk about is 3-inch. 3-inch can go up to 34, but if you remember in the book, it had 2 little asterisks, and what they meant was, yes, it will do 34, which would be several bathroom groups. The bathroom group was a sink, toilet, and tub or shower, and it would add up to, I believe it was 7, and because you put them all together, they gave you a bonus, and it was down to 6. So you could do like 4 or 5 bathrooms with 3-inch. However, you can only do 3 toilets with 3-inch. That's what holds it back. And those 3 toilets cannot be on the same floor. They have to be split. 1, 1, and 1, or 1, 2, or 2, 1, depending. So if you got 2 floors, you're probably okay. If it's a big ranch house and you only got 3 bathrooms back to back at one end, maybe a little lavette at the other end, you're going to have to do 4-inch, at least from the point where the third toilet's going to tie in. Okay. Now those things, I'm repeating what I did say on the video, but you really have to know them. Now, as far as memorizing the chart on page 168, I believe it was, for fixture units, not so much. Don't worry about memorizing charts. All right. Now, I've seen these charts for, many years, and some of them you can't help but memorizing at least part of the chart, but don't worry about that. But the fixture units on the residential fixtures, you could pick that up in a matter of minutes because there's not that many fixtures that we deal with. Okay. There's very few at a residential level. Commercial, no. There's just a long list. In fact, the majority of that list on page 168 is commercial, and they're all over the map as far as the values. Don't worry about them. If they want you to figure something out for your license, you'll get the chart. All right, the math, I'm going to call this a math video. I was looking at the requirements for both Tier 1 and Tier 2, and they're really not that much different. A lot of math, and I haven't done some math, but not a great deal. Also, got some news for you, if I don't mention it when we go live. I happened to, for the first time, I added up the hours. I was talking with my boss, Deb, last week, and I think I mentioned to you that I was talking to her. But anyway, and I said we're coming up on the midway point. I said I haven't added up the hours yet, so I did. Now, I believe that you guys met once, or you got credit for one class with Deb or whoever she had registering you before I started with you at the end of September. I have September 28th as our starting date. Now, this I'd like you to all listen to, because when we go live tonight, I'd like you to inform me if I'm mistaken. I'm quite sure about the December 28th. In fact, I'd bet money on that. But I don't know what you did before that. I wasn't there. I think it was one class. So if it was one class, you have in before tonight, I believe it's 60 hours. Okay? Not a big deal. So what it means is we're at the halfway point, maybe a class of possibly even two classes over. All right, we still got a ways to go. But we're passing the, we're halfway point is definitely in the rearview mirror. All right. I thought we were still coming up on it tonight or maybe next class. So we're moving right along. And there is quite a bit of math, and I can't just blow it off and do other things that maybe are more interesting. Now, those of you who like math, well, you're going to like this. All right. But we have to do it. Now, I'm making a joke about it. Now, unlike the charts in your code book, this math that comes off those formula sheets that I gave you, well, you downloaded a couple months ago, I guess. Those you have to memorize. All right. There is no formula sheet for them. So all this stuff that we do with math, none of it is probably beyond, I don't know, 8th and ninth grade, but there's a lot of it. And some of it is confusing. Some of the numbers are similar and they're easy to confuse. And sometimes when you get the test, they won't try to trick you with answers that are like just a fraction off from each other. And but they are close enough that you can't wing it and just figure it out, on your own without knowing the formula. Okay, now the good news for you is that years ago, I don't know when, it was quite some time ago, the state started to allow calculators, excuse me, not computers, calculators, right? I long after my time, as far as getting a lot. I mean, my time when I say that, I got my licenses in the 1970s, and there were calculators. Or my brother had one in 1974. It cost $300 some then, which would be well over $1,000 today, and it was a big deal. It had the multiple. He's retiring this week as a professor at the University of Colorado. He became a professor. He was an architect, or is an architect. And about that time, years ago, he was going to school, and he showed me his calculator. It was like something from science fiction. It was very rare. So the state wasn't under any pressure to allow calculators because they just weren't around back then. And probably in the early 80s, that there was some talk about it, but the state resisted for quite a while. So I was told. And now I understand you can bring in a calculator. Now, I do remember them saying, even years ago, that you can't bring one in where you can program and all kinds of other stuff, where you would, with today's phones, let's face it, you could put everything we're doing, I guess, in there. So I don't know how that works. Whether or not maybe they give you some basic calculators when you walk in. That's something to find out. And also, if anybody knows the answer to that, when we go live, please let us know. Okay? But the last I heard, you can use calculators. The only thing with the calculator is this. If you're doing it longhand, like we did years ago, they can only give you so much, because some of these problems do take time. But if you got a calculator, I mean, they can bury you with problems, and you got to fly on that calculator. So anyway, let's not beat that. I won't beat that to death anymore. Okay, now switching over to what I'm calling the math video. Real quick review. Circumference. How do you find circumference? Circumference of a circle was pi r squared. Remember that? 3.14 times the diameter, which is the distance across the circle. Radius was half the distance. And another one was BTU, big one. Now some of these formulas, they're valuable for your license and not much else, right? And which you probably already know that. But some of them, like this one, BTU, that's a big deal for your license and for out in the trade. You absolutely have to know this, especially when you're doing heat, baseboard heat, radiant heat. BTU is part of the game. All right. The boiler is rated in BTUs. Gas, oil, it doesn't matter. Right? It's rated in BTUs. Input, the higher number, how much gas does it need for an hour? And output, how much heat can it put out? All right. And there is a difference. We'll say 150 coming in, 130 going out, 20,000 goes the boiler room, up the chimney, who knows. Okay, so you have to understand all that. And let's see, BTU. Okay, what is a BTU? You should be able to answer it right now without looking at your notes. 1 BTU is the amount of heat needed to heat 1 pound of water 1 degree centigrade. 1 degree, excuse me, not centigrade, Fahrenheit. Right? We don't deal with centigrade. Okay, so just picture a little bag of water and a candle. We'll say, of course, the candle would burn the plastic, but if you could actually capture all the heat, a very brief time it would take to raise that water 1 degree from 70 to 71. That's 1 BTU. It's a tiny unit of measure, right? A foot. I'm standing in my living room right now. I'm looking at the baseboard. That's standard 9-inch baseboard. This house was built in '93. I remember that stuff. We were using it back in the '70s and the '80s. It looked just like it, and I suspect you're using it today. It puts out 600 BTUs per foot at 180 degrees Fahrenheit, right? That's a lot of BTUs for 1 foot. Okay, the radiant heat is a lot less because you put, where you might put 20, 30 feet in a room like this, you're probably going to put 100 feet of, at least 100 feet of radiant in here because the output is much less. The tubing puts out a lot less heat than a piece of copper with fins, and it's also running much cooler. For those of you who haven't done it, this I'd like you to ask me about sometime. I could make a video on radiant heat. I'm not a big resource on it because I've only done one complete job, but I have been around it, classroom, and talk with people about it. And for those of you who haven't done any radiant heat, I'd be happy to give you a little video on that. Okay, we could talk about it. And the mystery to me, even until the day I put it in, and well, not the day I put it in, but before I started, was how do you get the boiler running at 180, 200, because that's what they run at, to put heat in the radiant tubing around 100 degrees or whatever they designed it for, 100, 105. And it was a mystery. And there is an explanation for that. Very clever. Okay, so much for BTUs. I'm getting off on a little tangent here, didn't mean to. The other one we did was specific gravity. And again, this is a quick review. This one you should know. This is an easy one. Don't give away test points. Specific gravity is the weight for a solid. It would be the weight of, they pick water. I mean, there's nothing more than half the earth is covered with water. So that's the standard. Specific gravity of water is 1. Okay? And every other liquid is based on that. And the one that they actually cover in your formula sheet is mercury. Don't know why, but that's the one they picked. Mercury, because of maybe the contrast. Now, years ago, we did the mercury in the thermostats, and I think somebody asked me about mercury to test gas, and I believe I answered that question. We did have you pump up the gas, and if there's no leak, the mercury would hold in that tube, and if there was a leak, it would fall. Kind of common sense. But once you pump it up, it's going to have a little bulge in it, almost like when you pour lead. How the lead actually, before it runs off, it actually kind of bulges up a bit. Well, the mercury does. And if there's a leak, before the liquid drops in the tube, you'll see it go from like this convex to concave, where it goes the other way, right? It caves down, but it doesn't move on the glass. And then once it's concave and there's more of a loss of pressure because the leak is causing it, then it will drop in the tube. All right. So that's mercury. And the mercury in the old T87 thermostats, which you've all seen, the round ones that are on the wall of a lot of houses, is still out there. And they work very well. Right? They're excellent thermostats, but they're out of the system now. Okay. Those are just a few things I want to review. And this I'm going to start with is probably the easiest thing: square inches and square feet. All right, so let's take a look at that. I don't believe we talked about it. I'm going in the order that it's covered on the sheets. This would be the second page. Square inches to square feet. So if you've got square inches, how many square feet? Okay, divided by 144. So if we got 288 square inches equals how many square feet? Just divided by 144. You put it up here. Okay, so we have 288 divided by 144. Like that. Okay. Obviously, I picked an easy one. I knew the answer. All right, so it's 2 square feet. Now, you want to make it a bigger number? All right. Let's say we have 2,880 square inches, right? Just add a 0. So we divide by 144, and we have 20 square feet. Okay, this is one of those book questions, book answers, where there's not much practical value to us, not that I can think of. But never know. Might be the one they're going to hit you with for your license. All right, so you divide 144 into however many inches. Now, if it wasn't nice and even like this, you would have point something up there. You just, add zeros and, stretch it out a bit. And my guess is on a test, you wouldn't have to take it like 5 places, maybe 1 or 2 places would be more than adequate, because if you had the right answer, it's going to be on the answer sheet. It's going to be the multiple choice that's same as your answer, right? You don't have to worry about being too close. So you don't have to carry it too many places. Okay. Now the opposite would be square feet. Going to square inches. Okay? So what we have is same thing. Let's say we have 20 square feet, which we just dealt with. 20 square feet. You multiply it. This one here, you multiply by 144 to get the answer, right? That's the solution. 20 feet times 144. And you come up with 2880, right? Very simple. Okay, just don't get them mixed up. Okay, I'm not going to spend any more time on this one because it is, it's obviously a pretty easy one. Just remember that 144, right? 12 times 12 is a square foot. Okay, who checked that? 50. Okay, we get a little more time. All right, on can't see the print. Hold on. Oh, this one we definitely haven't talked about this. Test pressure. Equals 2 times working pressure. Okay, what does that mean? Let's say that a water heater, will say, is rated for 100 pounds PSI operating pressure. Okay? You double that for test pressure. Operating pressure, test pressure. Okay, obviously, if you let's say you're going to be building water heaters, you're a manufacturer, and you're going to get into the business, Okay, long before you try to get it approved by the state, you're going to be building this thing. You can't have it so it's going to blow up at 110 pounds. I mean, that's common sense, right? It might surge. Who knows what happens? So it's got to get to 200 pounds safely before you can even think about having this thing approved. All right, now there is another one. I don't even want you to take notes on this, but I do remember somewhere in the book, there's something about a distortion test. You would take this and hit it with another 25%. And so it would be beyond test pressure. And that would be the point where it would have to hold together without distorting. In other words, starting to pop rivets and about ready to blow up. Okay, it would have to hold its shape. But the main thing is, and this is on the formula sheet, is from operating pressure, we'll say 100 to test pressure. I'm not sure what they're rated for, but I don't imagine it's much less than this. Now remember, legally, you cannot have pressure in the house exceeding 80 pounds. Could it happen? Of course it could happen. Something could malfunction. You might have a pressure reducer. Somebody screwed around with it, dismantled it, took it out to get higher pressure, and maybe you have 100 pounds. But you don't have to worry about 200 pounds, right? You're going to break everything. I mean, ball cock, faucets will be all screwed up. People will be getting blown across their shower. Not going to happen. So the test pressure is probably pretty safe. You know, think about it. You're building a bridge. Same thing. The only time they sweat a bridge is if like they have huge crowds going across for some big event. The Golden Gate, the anniversary of the 50th anniversary, I think it was. They had wall-to-wall people on the bridge. It far exceeded its design, and I know they were sweating it out that it would hold, and it did because the test pressure. I'm sure that it was designed to far exceeded the operating like everyday traffic that's on the bridge. Okay, an easy one, but just remember that test pressure is 2 times the operating pressure. Okay, and I'm going to introduce something here, and then we're going to move on to. I'm coming up on a half hour. I don't like to go much over half hour on these videos. So this one here is another one I think we talked about briefly. This is going to be water pressure. Now, as I've said to you before, and I hate to sound like a broken record, but I really could use some updated test questions. Nothing illegal, you know, stuff that you remember. Let me tell you what happened. For those of you who haven't heard this story, you know, some of you did. For those of you who heard this before, I apologize. But for those of you who haven't, back in the relatively early 70s when I was in night school, early to mid 70s, my night school teacher used to ask us, when you take the test, remember, pay attention to what the questions were. And as soon as you leave the test, like out in your car, bring a notebook and jot them down. Bring them in. We'll kick them around. And that way, if you fail the test, he could go over all the answers. And then for everybody else who hasn't taken the test, it's like a gold mine because you got the latest, up-to-date test questions. Now, you might not get the same question, but you know what area they're focusing on. Roof drains, gas code. And I've heard that it kind of changes. Plus, they have a pool of answers. I've also heard this, and I think this is true. We'll say they have 5,000 test questions and answers, and they rotate them around. But you'll see what they're focused on now. And they were very valuable. And I did the same thing. I remember clearly when I took my journeyman, I came out to the car and I wrote all this stuff down that I could remember. I would say I remembered. I don't have a photographic memory. Wish I did. You could have a lot of money, but I wrote down what I could remember, which was more than half, definitely more than half. And other guys did the same thing. So for those of you who take the test, now obviously doesn't apply to you guys because you're all tier 1 and 2. But if you co-workers, especially the ones you're friendly with, ask them as a favor, even if they don't write it down. You know, what was big? You know, what did they cover? You got to ask them fairly soon after the test because this stuff just kind of fades away. All right, so ask your coworkers to give you a heads up on that because that's huge. Because we don't get that, whether you're an inspector or a teacher, we don't see that stuff. All right, we got our license, we have no access to that material. Okay, so please do that. All right, getting back to, and I'm going to introduce this, and then we're going to switch over. 1 pound per square inch. That's another big one for your license. 1 pound per square inch on a gauge, we'll say a sensitive gauge, and you have a pipe. This is at the bottom with a cap on it. You fill it up with water. Equals 2.31 feet. So if this was a piece of pipe right here, we'll say this black border, cap on the bottom, gauge, and I started filling this pipe up, I would get up to about, there's 1 foot, 2 feet, about right here, 2.3 feet, 2 1/3 feet to get 1 pound of pressure. Okay. All right. I'm going to switch over to another video. I will see you guys on the, where's my mouse going? The mouse is asleep. There he is. I'll see you